everyone, this video is for lesson 1-5, which is exploring angle pairs. So by the end of this lesson, you should be able to identify angle pairs and then use their relationships to find different angle measures. So this is a quick little thing if you wanted to try it out. It says the 5 game pieces at the right form a square to fit back in the box. So it's almost like a little Rubik's Cube kind of thing to think about. 2 of the shapes are already in place. Where do the remaining shapes go? How do you know? And you could also make a sketch of the puzzle to complete it. So if you want to try that, you can go ahead. We're going to get right to the lesson. So here it is. So before we actually get into dealing with relationships to find angle measures, we have to talk about the different terms that represent relationships. So the first vocabulary term that we're going to talk about are adjacent angles. So if you take a look over here, what we have is we have some adjacent angles. We have angle 1 and angle 2, and then angle 3 and angle 4. So angles 1 and 2 are adjacent angles, as are angles 3 and angle 4. So first, the thing that I noticed about angle 1 and angle 2 is that angle 1 and angle 2, they're like next to each other. So when I think of adjacent angles, I think of 2 angles being next to each other. But by definition, if we're talking about adjacent angles, we are going to talk about angles, 2 angles, with a common side, as well as a common vertex, and no common interior points. Okay, so by definition, that is the definition of adjacent angles. 2 angles with a common side, a common vertex, but no common interior points. And if you take a look in these 2 diagrams, the sides that they share, so angle 1 and then angle 2, should have drawn in this color here, angle 2, if I could trace over it, right? They share this side right here. And if I do the same thing for angle 3, right? And then angle 4, they share this side right there. So those are your adjacent angles. Okay, so now we can move on to vertical angles. And before we even say anything about vertical angles, put a big star next to vertical angles. Vertical angles are going to be angles that we talk about all the time. And truthfully, if you take a look, you have angle 1 and angle 2. And then 3 and 4. So first, before we say anything, what do you notice about angle 1 and angle 2, and then angle 3 and angle 4? So right off the bat, I see that angle 1 and angle 2, they're opposite each other. Oops, I don't know what's happening, sorry. So why isn't my text box working? All right, so we can think of vertical angles as being opposite. Okay, but again, there has to be an actual definition for vertical angles. So here it is. So vertical angles, so like we said, angle 1 and angle 2, as well as angle 3 and angle 4 are vertical angles. So by definition, vertical angles are formed by 2 straight intersecting lines. So if I take a look here, my intersecting lines would be here and here. And then those intersecting lines form angles 1, 2, 3, and 4. So the angles that are opposite each other are the vertical ones. Now, in addition, the vertical angles have a super important relationship. They're equal. So I know that angle 1 and angle 2 would be equal, as well as angle 3 and angle 4. The angles have sides that are also opposite rays. That's just another way to kind of check to see that you have vertical angles. All right, so then we can move on to the next page and talk about complementary angles. So complementary angles, we have angle 1 and angle 2, as well as over here, A and B. So for complementary angles, this here, complementary angles, two angles whose sum is 180. Now for complementary angles, they do not need to form a straight line, which is interesting, right? Because typically we think of complementary 90 degrees, we always think of that little right angle. But if you take a look at what we have over here with A and B, right, they just add to 90 degrees. 47 and 43 gives me 90. Two angles that are complementary, they're known as having complements. Okay, now similarly, we have supplementary angles. So when we have supplementary angles, two angles whose sum is 180 degrees. Now, like complementary angles, for supplementary angles, they do not need to form a straight line. So again, take a look at what we have at angle C. Hey, there's no other angle. So we could have just two angles. We could say like angle C and angle B. So C and B here, they could add to 180. Like complementary, if you have supplementary angles, they're known as supplements. And there we have it. Okay, so those are like the angle relationships. They could be equal, add to 90, or add to 180. Oops, and complementary here, I see an error. They should be 90. So fix that for complementary. Okay, so let's now try to identify some angle pairs. We say that we have here angle BFD. So I'm going to trace angle BFD. And angle CFD. So we ask, are these angles adjacent? So take a look. Are they adjacent angles? So that means that they have a common vertex, a common side, but they shouldn't have any common interior points. And if you take a look, that's an issue because C is in the interior of angle BFD. So these are not adjacent angles. So let's right here have an explanation. No, they have a common side and a common vertex, but they have a common interior point, point C. Therefore, they are not adjacent. So that would be our explanation. All right, let's take a look at the next one. We have ABF and EFD are vertical angles. Let me erase. So AFB and EFD. So are these vertical angles? So we take a look and the problem arises right here with FB and EF. So remember, vertical angles have to be formed and have opposite rays. EF and FB are not opposite rays. So there's our issue. So if we have to answer a question, are they vertical angles? No. FB and FE are not opposite rays. And then we're done. Fix this a little, make it capital. Okay, then finally, letter C. They want to know angle AFE and angle BFC are complementary. So we have AFE and then BFC. So we have 62 and 28 is 90. So are they complementary? And very simply, we can state yes, their sum is 90. Done. And that's how you would work to kind of reinforce the angle relationships and work in that matter. So let's go on now. And you guys should pause and try these out. And then I will go over them. So at this point, like I just said, you should kind of pause and try them. I'm going to go over the answers right now, though. So they want to know for A is AFE as well as CFD. Are they vertical angles? So here I take a look and I notice that, yeah, they have opposite rays, right? So that they are definitely vertical angles. So yes, FA and FD, as well as FC and FE, are both opposite rays. All right, how about B? B says that we have angle BFC and angle DFE are supplementary. So we can test that, right? We have to see supplementary means 180. So 118 and 28. Oh, no way, right? That's not going to give us 180. So our answer here, simple. No, their sum is not 180. Done. All right. Again, moving on. Now we have, erase this. We have angle BFD as well as angle AFB. All right. They want to know, are they adjacent angles? And yes, they are, right? They share vertex F. They share this side, but they don't have any common interior points. So it's perfect. They fit the criteria. Yes, they share vertex F, side FB, and have no common interior points. Done. All right, let's move on. Now, this is just interesting because this is just some information, and it's basically telling you that once you have a diagram, you can conclude the following information regardless of if it's marked. Meaning you don't have to have the tick marks or the arc marks to figure out that you have adjacent angles, supplementary angles, or vertical angles. But what you cannot conclude based on an unmarked diagram are that angles are congruent or segments, or an angle is a right angle, or angles are complementary. So you have to make sure that you see a right angle symbol in order to know that angles are complementary. Same thing for angles or segments to be congruent. They have to be marked as congruent in order to assume so. So with that being said, you can kind of take a look at this diagram and we can answer some questions. Let's see. Are angles 1 and angle 2 congruent by the marking? So look at angle 1 and I look at angle 2. They have those arc marks, so yes, that's true. Okay, 3 and 5 are vertical angles. Now remember, vertical angles, I'll take a look at straight lines. They don't need to be marked vertical in order to be vertical, and they are, so that's true. Now it says that we're dealing with some adjacent angles. Let's see. Angle 1 and angle 2, they're adjacent, okay. 2 and 3, they're adjacent. Now we're going to go to 3, angle 3, and angle 4. They're adjacent. 4 and 5 are adjacent, so that's all good, right? All these angles, one right after the other, that they share a common side, they're adjacent angles. Okay, so all of that is true. Now let's take a look at the second part. It's saying that angle 3 and angle 4 are adjacent and supplementary. So that's true. They're next to each other and they form a straight line. Okay. Then it says 4 and 5. So here's angle 4. Here's angle 5. Same thing. They're adjacent and form a straight line. So yeah, this is true also. And then we take a look. 3 and 4, if they're adjacent and supplementary, they add to 180. True. Same for 4 and 5. Perfect. Okay, so it just kind of goes to show that you can have a diagram that's marked and then unmarked, but we still gain a bunch of information. So now let's see if we can conclude each from the diagram. Okay, so one says that TW and VW are congruent, and they are because they have tick marks. Yes. B, PW and WQ. We can't because there are no tick marks. I don't know for certain based on the tick marks, right? There are no tick marks, so I can't make assumptions. All right, let's go to the next one. TWQ is a right angle. Once again, there is nothing that shows me that it's a right angle, so that's a no. If it gave me a little right angle box in here, I could say yes, but it doesn't, so can't just assume. And then it says that TV bisects PQ. Well, if PQ got bisected, I should have tick marks here, and I don't. So that is also incorrect. So the only thing that I can conclude is the first thing because I have 2 tick marks here and here. Everything else is lacking in the tick mark situation, so I can't. All right, now let's take a look here and see what we can say. So it says, look at the diagram to the right. What can you say about angle ABD and angle DBC? So one thing that I noticed about these 2 angles is they're definitely adjacent, right? And they also form like this straight line or a straight angle. So what that actually gives me is a new piece of information. So when 2 angles, such as these, when I have 2 angles that form a straight line and are adjacent, they're actually called a linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays, and the angles of a linear pair form a straight angle. Okay, so here's the thing. If 2 angles form a linear pair, then their relationship, if they form a straight angle, they sum to 180. They're supplementary. All right, so now we're going to use this information and we're going to try this out. All right, so here it says, angle KPL and JPL are a linear pair. Okay, so let me draw this out, right? KPL, notice PL repeats in both, so that's their common side. So I'm going to draw, I have K, P, L, and then J, P, L. There we go. And then it says KPL is 2x plus 24. JPL is 4x plus 36. Okay, we have to find the measures of each angle. So what I know is that together these 2 angles form a linear pair. That means that they sum to 180. So I'm going to do 2x plus 24 plus 4x plus 36 equals 180. From here, I can combine like terms. I get 6x plus 24 and 36 is 60 equals 180. Subtract 60. 6x equals 120. Divide by 6. And x is 20. So now, if I have to find each angle, I'm just going to substitute in, right? X is 20. So for angle KPL is going to be 2 times 20 plus 24. So 40 plus 24, that's 64 degrees. Then for angle JPL, that's going to be 4 times 20 plus 36. So that's 86 plus 36, that's 122. And so we have to do 4 times 20, that's, 80 plus 36, that's 116. Let's change this to 116. Okay, and there we have it. And a quick little check on the next page, it says, how can you check your results? Well, think about it. Those two, 116 and 64, has to add to 180. And they do, so we know we are good and accurate. Okay, so here again is another practice. So you can go ahead and try that practice out. And for this, the answer key for this question will be up on posted at 122, so you can check your work with that. And I'm going to move on now to talking about angle bisectors. So like a segment bisector, we can also bisect an angle. So if you take a look here, I know that this angle was bisected because AY splits it and creates 2 equal parts with those tick marks. So I know that for sure. So it's being split into 2 equal angles. So an angle bisector is a ray that divides an angle into 2 congruent angles. Now what's interesting is the endpoint of the angle bisector is at the angle's vertex, right? So if you look here, the endpoint of this ray, or the angle bisector, is at the vertex A. So if you take a look at what we have, it says that AY is an angle bisector of this angle. So here it is. So that means that this angle is congruent to this angle. Remember, 2 angles that are congruent are also equal. So an angle bisector creates 2 equal angles. One angle here, another angle here. And those would be your congruent angles. So similarly, now if we're going to create a little equation to go with this, take a look at what we have here. It says AC bisects angle DBA. So we have DAB, AC cuts through it. If DAC is 58, they want to know what's the measure of angle DAB. What's the whole angle? Well, think about it. It was bisected, so these pieces are equal. They're both 58. So to figure it out, I could just do 58 plus 58, which is 116. So we have choice D, which is 116. Pretty easy with the angle bisector. And it's very similar to this here. If we have KM bisects angle JKL, and these are equal then because it's being bisected, JKL is 72. So the whole thing is 72 and is bisected. What's the smaller piece? So that means it's cut in half. We divide it by 2 to get 36. Cut into 2 equal parts. Each piece is then 36. Okay, so that finishes up lesson 1-5, which is exploring angle relationships and angle pairs. You can go ahead and go on to try the lesson check and check your answers with the keys. If you have any questions, please feel free to email.